Welcome everybody to our session today. Today we are running our second workshop day for Think Big, Start Small, Youth-Led Robotics for Multidimensional Climate Solutions. So today everybody will have received their kit at home, and so today we can really commence with our virtual STEM and robotics program. This is our first practical workshop. So today what we're going to be doing is we're going to be covering the onboarding, how to get your kit up and running, and we're also going to have a look at a number of topics relating to climate action. So let's have a look at our overall format for today. First of all, we're going to have welcome and introductions. We have some fantastic guests from the United Nations Development Program, from UNICEF, from our sponsor, the Danish Embassy in South Africa, who are going to be welcoming us and sharing with us why this program is just so important for us, and why we've decided to embark on this initiative. Our delivery partners, Cybono, they're also going to greet you and say hello, and then you'll have an introduction from all of us who are going to be supporting you in the workshops. After we've done that, what we'd like to do is we'd like to take a screenshot, a nice big group photo. So we'll let everybody prepare that. If you want to turn your camera on, that'll be great. And we can all put these wonderful smiles on our faces and we can take that screenshot just so that we can make sure we remember today. We will then go into building our kits. We're going to do an experiment, collecting light data, and discuss that. And then during our break between 12 and 1 today, we are going to have some breakaway rooms where you're going to meet your mentors, and then we can just really catch up to make sure everybody has their kit working and they're able to conduct the experiment. After that, we're going to have a discussion about natural light, ultraviolet and solar energy. We're going to start talking about robotics. We're going to start designing our robotics experiments. And then what we'll do is we'll go through what are the experiments to be conducted this week with your kit, and we'll have a conclusion. So without further ado, by the way, that's me. I'm Judy Sandrock. I'm South African. I'm actually based in Cape Town. And I spent many years in my life in a career as a chemical engineer. I've worked in a number of industries. I specialized in environmental applications and water treatment. So please forgive me. I'm going to ask for forgiveness right up front. During these workshops, I'm not a teacher, so I'm not going to be, I find it very difficult to engage as a teacher per se. So what I'm going to be doing is I'm going to be engaging with all of you as either as budding engineers, aspirant engineers, so yeah, if I get too technical, you have to stop me, then I'll be able to explain myself. Okay, so that is me, and what I would like to do is I would now like to actually hand over the baton to the United Nations Development Program. And so I think what I would like to do actually is, if it's okay, could we actually start with Tove? Tove is our project manager from the United Nations Development Program. And so Tove, is it okay? Please, if I can just hand over to you to introduce the team from UNDP.
Absolutely. Thank you so much, Judy, and good morning, everyone. It's a pleasure to finally meet you. I'm really looking forward to engaging with you and following you through the journey this coming month. So my name is Tove Nordberg, and I work as a Climate and Environment Associate at the United Nations Development Program in South Africa. And I'm also the focal point for this project. So I've been working very closely with Judy, Cybono, UNICEF and Embassy of Denmark in delivering this project. But let me hand over to my colleague Nokuthula Mene, who will do a few introductions on why we are focusing on this project and why it's so important for us. So thank you very much and good luck for the first workshop today and for the following workshop series the coming month. Thank you. Over to you, Nokuthula.
Thank you, Tove. Good morning, everybody. My name is Nokuthula Mene. I work for the United Nations Development Programme Country Office here in South Africa. And I'm here to represent the Nature and Climate Energy portfolio under which this project is located. The United Nations Development Programme is a proud implementer of the pilot project, Think Big, Start Small, Youth-Led Climate Robotics for Multidimensional Climate Solutions. Youth and Climate Robotics for short, under which these learner workshops are being organized.
Hello.
I would like to take a moment to acknowledge the project partners. I'd like to start by acknowledging Judy Sandrock from FemSTEM and all the facilitators involved in this project. I'd like to acknowledge Akash Jusrath, Selindo Kuhle Mbobane from Saibono. I'd like to acknowledge Toby Freaker from UNICEF. And I'd also like to acknowledge Blessing Nechironga from the Embassy of Denmark, who have already been highlighted as the sponsors for this project. It is a pleasure to work with you all in the implementation.
It's online.
It is a pleasure to meet with all the educators as well that have been trained through the project and might be in this session. It is especially a pleasure to interact with the 72 high school learners that have been selected to go through the training program. Congratulations to you all. As the United Nations Development Programme, we work in more than 170 countries across the globe, helping countries to eradicate poverty, reduce inequalities and exclusion, and build resilience so that countries can sustain progress. We also play a critical role in helping countries achieve the 17 Sustainable Development Goals set out to be achieved by 2030. A core mandate of the UN, as well as the United Nations Development Programme, is to leave no one behind. In line with this ethos and all our work encompasses an inclusive approach, ensuring that women, youth, people with disabilities equally benefit and participate in society. We designed this unique project to tackle three main areas: climate change, youth opportunities, especially for girls in science, and the digital revolution. Both globally and in South Africa, we are facing the threat of climate change. In addition to this, we continue to face persistent challenges related to poverty, inequality, and unemployment, all of which has been exacerbated by the COVID-19 pandemic. At the same time, we find ourselves in the era of the fourth industrial revolution, where the digital world has the greatest potential to catalyze a green and sustainable economy. To leverage on the possibilities that the fourth industrial revolution and STEM offer, we need to build various skills in the digital economy. And naturally, you, the youth, are the most important target group as we want to achieve this, as you are the future of our country and of the digital economy, and of the global and digital economy. That is why we have designed this unique project, the Youth and Climate Robotics Project, targeting both the need of skills development in the digital economy, as well as the need for increased environmental awareness, the application of digital skills to solve energy, climate, and environmental related challenges. Through this project, we, together with our project partners here today, will be providing training to 20 educators and 72 learners across the country through digital workshops much like this, implemented over 6 months using innovative Dinnerbox satellite kits. I would like to take this opportunity again to congratulate all the learners present here today for being selected from over 250 applicants to participate in this program that will run through September, covering areas of SDG 7, which is on climate action, SDG 13 on climate action, SDG 7 on energy, and SDG 15 on life on land. I'd like to wish you all a successful series of workshops where you'll be exposed to new challenges and concepts, acquire new skills, interact and learn from each other. I encourage you to take advantage of this opportunity and be active participants. I look forward to hearing about your experiences as you undertake this journey. I would like to thank you all and leave you in the capable hands of Ms. Tove Nordberg and our other project partners. Thank you.
Fabulous, thank you. Thank you very much for that marvelous introduction. Now what I'd like to do is that I'd like to hand over to Blessing, who's joined us from the Embassy of Denmark. Blessing, please, can I hand over to you?
Absolutely, Judy. Good morning to all the learners and all the facilitators and all our partners that have contributed so much to this project and availed themselves to embark on this journey. What a privilege to sit among the future scientists of the world. Welcome to all the learners, and thank you so much for participating in this very important project. We as the Embassy of Denmark value issues that are related to climate change and trying to contribute to a greener future. I'm also very pleased to be among people that are doing so much in terms of educating young people, young scientists that will make a positive change in the future. Judy, thank you so much. Tove, thank you so much. Our partners at Saibono and everyone that is contributing to this project. I will not take much of your time talking about politics because I feel like what we are doing is contributing to things that are practical that will benefit us as young people in the future. So I also have my box right here and we are ready to go. I wish you guys a successful workshop. All the best.
Blessing, fantastic. Yes, thank you very much. Yes, you received your kit and everybody has their kits. So yeah, we're looking forward really to raring to go for today. What I'd like to do now is I'd like Tony Fricker, please, from UNICEF. If you wouldn't mind, Toby, introducing yourself.
Sure, no, great. Thank you so much, Judy. Thank you, and thank you, everyone. My name is Toby, and I work for UNICEF here in South Africa. And I mean, first of all, let me say congratulations again to everyone for being here. And you already have come a long way, so it's really excellent to be connected with everyone. And also thanks to our partners, to everyone for having UNICEF here today and for letting me say a few words. I'll be very quick. But I think, yeah, I think it's amazing. It's great to have the energy, the creativity of young people on this project. And I think it's, you know, it could not be more important. And I just want to mention very quickly, UNICEF put out a report just about 10 days ago, actually, on looking at the specific impact of climate change on children and young people. And in South Africa, it's sort of honed down in on water pollution, soil pollution, and water scarcity as being some of the key issues, you know, affecting children and young people in South Africa. And as you're all aware, I'm sure, you know, there's also the, you know, South Africa is a big greenhouse gas emitter, and air pollution is not ideal in some places. So I think, you know, your role is so important in tackling these issues. And that's from, you know, local solutions to the bigger sort of policy level issues. And from a UNICEF point of view, just to mention that we, you know, one of our key advocacy, key points is to really support you as much as we can to bring your voices, bring your ideas to the policy level, to bring that into the climate change discussions, and to really promote and bring your creativity across. So that's why I'm so pleased that UNICEF can actually partner on this with you, and we can support as much as we can. But the real ideas I know are coming from you on the ground, from your creativity, and we're really looking forward to seeing what comes out of the project as a whole, and the broader work that you do at school, but also outside school, you know, in the STEM field as well. So just thanks so much again, and I hope everyone enjoys the session, and look forward to connecting shortly. Over.
Fabulous, Toby. Thank you so much for your support, and I'm sure that we have a very ambitious group of youngsters. So when you offer to say we want to support you, I can guarantee that you are going to be taken up on that. Later on, we're going to be assigning mentors for everybody. So if it's okay, what we could probably do is we could channel some of those conversations via the mentors, so that we can really engage with you, because yes, you know, what's really important is that everybody has a voice. If we don't have a voice, then we can't be included. So yes, thank you once again. Akash, please, I'd like to hand over to you to introduce Cybono as our delivery partner and our partners in this wonderful initiative. And could I please hand over to you to introduce yourself and your team?
Thank you very much, Judy. I hope you guys can all hear me. It's been great thus far. Morning to our colleagues at UNICEF, UNDP, and the Danish Embassy. I'm so glad that Cybono can be part of this project. For all of you that don't really know Cybono, but we're the largest science center in Southern Africa. And one of our main goals is to promote public awareness of science, technology, engineering, and maths. And so we're very passionate about this project. We're working together with Celine Kushler, who's also on the team. And I'm so proud to see the amount of learners that have taken up this opportunity, because there's a lot of these type of opportunities that exist, but it really is up to you as an individual to make the most of it and make the right choices to be part of these type of opportunities that come your way, especially during your schooling career. Because at the end of the day, you guys are the next generation of scientists, mathematicians, engineers, and it is really up to you to be making the breakthroughs in science to help change the world, change the lives of each and every one of us. And congratulations to all of you students who are part of this project. I'm sure you guys will have lots and lots of fun. You've already been through one introductory workshop, and we're looking forward to seeing some innovative projects that are going to come out of this. So all the best and enjoy. Thank you.
Akash, thank you so much. That was absolutely wonderful. And Slee, I was wondering if we could just have a greeting from you. And what I'd like to do as part of my introduction to Celine Dokule is she hosted the most fantastic event the other evening, on Thursday evening, relating to various forms of renewable energy, especially wind energy. So I was wondering if you just wanted to wave hello and greet our team this morning. Hi, Slee, we can see you. It's breaking up a little bit, but it's wonderful.
Hi, Judy, and morning to everyone. I think
Great, absolutely. Slee is breaking up a little bit. So what I'd like to do is, before we start our workshop, what I'd really like to do as well is to introduce you to our mentors and our co-facilitators. So what I'd like to do is, Brittany, please, if you wouldn't mind introducing yourself quickly, and then actually handing over to our colleagues. Perhaps, Brittany, after you, let's meet Colin, Nico, Milena, if Milena's able to join us as well today.
Hi, good morning, everyone. My name is Brittany Bull. I'm also located in Cape Town in the Western Cape. I'm currently a student and facilitator in this program. I'm a university student. I was once an intern at STEM and X in a Box during my gap year at high school. And before that, I met Judy as one of the beneficiaries of a STEM program, much like this one, before X in a Box was as advanced as it is right now. I'm super excited to be a mentor and facilitator for this program, because I was once in your position as a student, and I'd love to give back and share in your learning journey with you. I was in the United States to study space systems engineering. So if you want to know anything about that, I would be the person to talk to. And next, Colin, if you'd like to go.
Thanks very much, Brittany, and good morning to everybody on the call as well. My name is Colin Mamdou. I'm also based here in the currently cloudy and cold Cape Town. So yeah, if anyone else is from Cape Town, please can you say hi or wave onto the call? It'll be great. Essentially, during my daytime, I currently work for a large telecoms operator, but the things that really gets me out of bed are four things. It's science, it's technology, it's engineering, and it's mathematics. And that's why I'm actually on the call today. So for me, it's a great passion. Very proud to be part of this really important initiative and be by your sides and sort of recruiting you onto the Green Army in saving the world ultimately. And I think my role throughout the day and throughout your journey as well is to provide you with any type of support that you require. Always feel free to raise any questions that you'd like. Perhaps with that, I'd like to hand over to my co-facilitator, Milena.
Good day, everyone. I'm a teacher in a primary school, and I facilitate very talented children in my school that in my science club. I'm very proud of the ones that are here on the call today, that went through the steps and qualified. And I'm also looking forward to implementing the program with the rest of my science club. My degree, I have a background in meteorology, master's in meteorology, and also honors in education. Currently, I'm an educator, but I'm also creating at the moment, I'm busy creating a program to help FEM-STEM with education about weather and climate. And I'm looking forward to helping all the learners, the ones that are going to be my mentees, and the rest of you understanding weather and the parts of the weather better. Thank you.
Milena, thank you. Thank you so very much. And Nico, can I hand over to you? And then after that, Vanella, if you could introduce yourself.
Yes, sure. Morning, everybody. My name is Nico Low. I'm based in Strand, Western Cape, close vicinity of Judy. I'm actually on the opposite side of the ocean. Colin, I think you in the other side. In the other ocean. I come from an electronics engineering background and IT project management. So in different industries, I'm super excited to be part of this team as a facilitator. My passion is to share my knowledge and my experience with the future workers, you know, the future learners. So I'm very glad to be part of this session. Thanks.
Right, awesome. Good morning, everyone. My name is Bane Lemoy, all the way from Soweto, Dobsonville. I'm passionate about science, technology, and I've built a studio where we do talk shows and host conferences and stuff like that. So I'm looking forward to meeting everyone, especially the mentees, and hopefully what I've gained over the years, because everything that I've done, basically, I'm self-taught. So I think this is proof that if you apply your mind in anything, then you can achieve whatever it is that you want. So I'm also learning how to code in C#, and I'm also a web developer at that, and everything is self-taught. So if anyone is feeling a little bit overwhelmed, it's okay. Everything can be learned. And I think with everyone here, the support, we should be able to find our way through. So I'm excited to be here. Thank you.
Wonderful, Banele, thank you so much. And what everybody will see is that Banele has, he's offered, and we've taken him up on that offer, is to actually build a website for our program to be hosting all of our content, all of our videos, experiments, and articles and things like that. So yeah, you're going to be apart from being a mentor, you're going to be seeing a lot of him. So that's absolutely fantastic. Thank you very much. What I'd like to do now, if it's okay, is I'd like us to be able to take a screenshot so that we can have a photo of everybody today. We have so many people in the group, and my screen is so small that what I'm going to be doing is that I'm going to be scrolling along. So I'm also very happy if all of you want to take screenshots, and then what we can do is we can see which one is the best. So if you wouldn't mind, if you're happy to turn your camera on, and great smile. And I'll make sure that I don't rub this eye. I've got an allergy today, so I must make sure that I don't look as if I'm have my eyes closed. That's absolutely fantastic. So you're all ready? Are you all ready? Okay, let me just find, have I got the correct keys here, Judy? Great, okay, that's good. And let's just take another one. There we go. Ivan, I caught you looking down. So let's try that one again. Wonderful. And then there we go. Oh, this is, it's so nice to see everybody. Okay, absolutely fantastic. So here we go with our third screen. Terrific. Excellent. Good. So let's go back to our plan for today. Right. So there we go. We've had our introductions. During the session, Brittany is going to be assigning you to different breakaway rooms for the break, and then and also introducing you to your mentors. So we've had our group picture. So now let's start getting into it. Let's start building our kits and understanding the fundamentals of instruments. So at this point, I'm going to stop sharing. And what I'm going to do is that I'm going to make sure that you can all see me. Okay, so at the moment, I'm not seeing myself. So I'm not sure if any of you can see. Can you see my video, everybody?
Yes, yes, you can.
Okay, so there I am. Okay, good. Right, so you all have your kits. A box that's got an Exner box label on it. So when we designed Exner box, we needed to find a name, and what we thought is, let's use Exner box because what is X going to be today? So in other words, what data are we going to be collecting today? What experiments are we going to be collecting today? So what I'd like you to do is, in your boxes, I would like you to please find four chippies. And so that is your SL01, okay, which is your light sensor, your OD01. You have a core that is a CW01 and an IP01. So there's also another thing that I'd like to show you, and that is that some of the bags are Ziploc, which is really great because then it's actually very easy to open them and then put your components back again. But some of them are actually sealed bags. So what I would suggest is when you cut open the bag, so right at the end, because you're going to want to reuse your bag. I don't want you to just kind of like tear it in the middle because you're going to want to put the components back in again. I'm getting a bit of a noise from sorry, Brittany, could you assist me in so everybody's muted, if that's all right? Okay, that's great. So let us go back to what were those four components again that we needed. So what we're looking for is we're looking for the SL01, the OD01, CW01, and IP01. So what I'm going to do is that I'm going to give you, let's say, 2-3 minutes to get all of that, to find all of those, as well as to open your bags. And also, oh, I forgot, the connectors. These are tiny little connectors. You're going to need the connectors to put your kit together. So that's absolutely great. So I'm going to give you just a few minutes for that. And also just a reminder, please use the chat. We're very happy that you use the chat. And I'm also very happy if you have any direct questions that maybe you don't want to ask publicly, please just direct those to Brittany herself. That'll be fantastic. We do have a question. What if some of them are unlabeled? That's okay. You should be able to see through, and you should be able to see that there's a little code on your chip that would say, except of course for those little displays, because they're covered in bubble wrap. So if you have the one where the unit is covered in bubble wrap, that's one of the ones that you want. That is the OD01, the little OLED screen. Okay, Brittany, what do you think? Do you think we're ready to start going again?
There are still some questions, maybe 2 more minutes for the students.
Fantastic, absolutely. Let's just give it a few minutes. I'm going to leave this slide up so that everybody has it. Okay, so we know what we're looking at. Okay, great. What I'd like to do is I'd like to start again. So does everybody have those 4 chippies? And yeah, that's what I'd like to do. Is I'd like to just start again. So what I would like you to do is, now that you have your 4 chippies, I would like you to find your SL01, as well as your IP01, and I'd like you to connect those 2. So you can see that the connector, there's a little tab between 2 and 3, and on the board there's a tab between 2 and 3. And so what I'd like you to do is I'd like you to connect them. You can connect to any side that you like. But what I've done is I've just put the one on top of the other, and you'll see why a little bit later. Why. What is important is that you can read. You see, you can read the code. So this one over here says SL01 and IP01. Now I know that they connected correctly. If I had done it like this, it could still connect. It could still connect if I did it like that. But now I can only read IP01. I can't read the other one. So you need to be able to read the different codes. So let me just put it back together again like that. So what I'd like you to do is that I'd like you to connect all four together. Please note that this one, the CW01, it doesn't have a connector port on the top. So this one is always going to be on the top because it only has 3 connector ports. With your screen, please be careful with it. Don't push down on the screen. Also, the thing is, if you find, this is what happened with mine yesterday, is that it came unstuck. So what I did is I just used a little bit of glue behind it to glue it back, or you can use double-sided tape or whatever it is. So we do have, at least we have these frames around them so that you're not going to be cut by the glass. But yeah, this is the most sensitive one. So just be a little bit careful with it. And so what I've done is here, I've put all 4 together. So you can see I have my CW01 on the top. Then I have OD01, my little display, and then my light sensor SL01 and IP01. It was very easy for me to do because my connectors are not new. Your connectors are brand new and your components are all brand new. So it's going to be a tight fit. So it's not that it's broken or anything else. Just you may need to push a little bit harder to get it to connect. So I'm going to give you just a few minutes to see that everybody's able to do that. Oh, Amir, I can see that you have your hand up. Do you have a question for me?
Judy, I cannot find the connector ports.
These little connectors, you should have a little bag of connectors.
Oh, I found them.
Okay, great. Good. Perfect. Please take your hand down so that I don't think that you've also got that you have another question. Fantastic. Thank you very much. Anybody else? Would you like, let me put the slide up again so that we can see what we're looking at. Let's just put that up again. Okay. Right, so what I'd like to do is, while you put that together, what I'd like to do is that I'd like to explain a little bit of what we're doing. And by the way, we are recording this session, so I'm going to upload it to YouTube later so that you can watch it again. What I've also done is that I have some links to much shorter YouTube videos about how to put your kit together, etc., and a little bit of background on X in a box. So, and that's a 6-7 minute video. So you will receive those links a little bit later. So don't worry if you're not able to do and hear all at the same time. You're certainly going to be able to catch up. Okay, so is there anybody else? Is there anybody who's struggling to put this together and hasn't got it together? Yeah.
The father is also saying he doesn't have an SL01. He only has an SL06. Okay,
that's absolutely fine. Okay, that's interesting. Okay, that's interesting. Not to worry, because what we can certainly the experiments that we're going to be doing from today onwards definitely involve the SL06. So use it in the meantime. Absolutely. If you want to use it in the meantime, it's not that the kit isn't going to work. It's also a light sensor. Is there anybody else, Brittany?
Yes, Tahira is the same issue. I just checked in one of my student kits as well, and it does only have an SL06 and not an SL01. So there may have been something with
okay
3 kits.
Absolutely, Brittany, I know exactly what that's about. What it is that with the students who receive their kits directly at home, those students have an SL01. For students who have received their kit from one of the facilitators or one of the teachers, that is a kit that is for use more in groups and more in classrooms, and those ones have the SL06. Okay. So all of the students who cannot participate by being in a classroom or by being in a group, everybody of those students has actually the SL01. So all of us who are isolated on our own will have the SL01. Anybody else who hasn't been able to, if you haven't been able to put your kit together so that it looks like this? Okay. Everybody up to speed?
Ma'am.
Great. Hi.
Hello, ma'am.
Hi. Yes. Go ahead.
I only have the SL01. I don't have the rest.
Do you have a CW01, the OD01, and the IP01?
No, I don't have those ones.
Okay, maybe if you, sorry, I'm just trying to find you in the room. If you wouldn't mind just turning your camera on and in your box, if you wouldn't mind just holding up, if you wouldn't mind holding up what you received in your kit. Sorry, Brittany, I need your help here. Sorry, I don't know which student it is who asked that question.
I've asked them to unmute and to start, but I'm still waiting. And then one student asked if you could repeat which pieces to connect. So maybe share the slide, because they had a connectivity issue for a little bit.
There we go. So we're looking for the SL01. Now the OD01, CW01, and IP01, they don't have labels on the bags. Okay, are we ready to have a look at what was missing?
Sorry, Judith, let me just ask, was that Izuna that was missing parts? I just want to know.
Yes, it was Milena. It was Izuna.
Yeah, please just see if we can assist him.
Did he receive the kit from you, Milena?
No, it's from you guys.
Okay.
I haven't shared my kits yet because I'm keeping it for my science club.
Okay, great.
And there are things that are unmarked.
Izuna, are you there?
Yes, ma'am.
Great.
Ma'am, my camera doesn't work, but there are 3 that are unmarked.
Okay. Okay, so those are the ones that you need. Can you open the bags and unpack them and see them? Are we winning?
Yes, Judy.
They all look like microchips.
Yes, they are. They are all microchips. And you should see that there is actually a code in the, for example, with the CW, most of them, the code is in the top left-hand corner. Okay. What I'd really like to do is I'd really like to continue. What we are going to do is we are going to have the breakaway rooms during the break. So if anybody actually still needs some assistance in putting their kit together, what I'd rather do is that we take it up during the break. So if it's okay, what I'd like to do is that I'd like to move on now. And so the next step is what I want you to do is I want you to take this kit and I want you to add power. So what I have is I have a power bank that I use for charging my phone, a USB power bank. What you can also do is that you can use a port on a computer. You can use one of those USB power sockets that we have in the wall. But what I'd like you to do is please add power. And tell us what it does.
Ma'am, I'm having trouble connecting them.
Okay, what we're going to do is we're going to look after you during the break. Okay, we're going to look after you during the break. So anybody else? Unati, I can see that you've put yours together. What is it doing?
It's lighting up and it's pretty cool.
It is, isn't it? Isn't it amazing? So yeah, what you have is you have a little lighthouse. And you've got a little lighthouse there that's showing a lux level. Has anybody else got their lighthouse running? Great, yes. And so the thing is, now you can see why I put it together in one long stripe. Is so what it does is it makes a little lighthouse. Okay. And then what you can see as well is that it's giving us a value in lux. So lux is a reading of natural light intensity. Okay, so that is always measured. The unit for that is lux. And then at the bottom in smaller letters, you can see that it says UVI. That is our ultraviolet index, our UV index. And since we're indoors, that's going to be extremely low. But wow, if you were to go outside, you would certainly see that increasing. So what do we need to make a circuit? So what I'm going to do is I'm going to share the screen again. And what do we need to make a circuit? What we need is we need 4 elements. We need an input, an output, a CPU or a processor, and we need to power our circuit. So we need our 4 elements. This is very important to remember because you've got many more chippies in your boxes that you received than just these 4. Okay, so if whatever circuit you want to build with electronics, you're always going to need 4 elements. That is an input, an output, a CPU or a processor, and power. Okay, so if we have a look at our kits that we have right here, our input is usually going to be a sensor. And in this case, what we have is we have our light sensor. So this little light sensor that we have, you can see that these little silver grains on the board. And so what it is that one of them is giving you your visible light in lux. So the visible light sensor, and then the other one is giving you your UV index, your ultraviolet light. So that is the input that we are receiving. Then the output. So our output is where we're actually seeing our data, and that is on our little screen. So you'll see that any of the sensors always begin with S. Okay, so if we have a look, our input SL01. So that is sensor light 01. Some of the students were talking about having an SL06. That is also sensor light 06. It's just another light sensor. They're still going to get the lux value from that. And then in your boxes, we're going to go through a little bit later what else you have, but certainly you have a number of different sensors that you've also received. Output always starts with an O. So we have O output display 01, which is our little OLED screen. So that's our output. Our CPU or processor that we're using at the moment. So that is always starts with a C as well. So this is called a Core Wi-Fi 01. And you'll see by the end of today that what we're going to be doing is we actually are going to be using it as a Wi-Fi chip. So this chip itself is great. It's being loaded with Arduino code. So it's very important to remember that, is that what we've done is we've pre-written Arduino code. And before we sent you your kits, we made sure that we flashed it with the code so that it would automatically run the Lighthouse. So that code is written in Arduino, and that's on our core, and that is our CPU or processor. And then, of course, we've got our power units. And in this case, we're using the IP01, which is our USB power. And so, yes, we've solved all four. What we have is we have an input, we have an output, as well as a core, and we have power. So everybody up to speed? I'm going to stop sharing now, and I'm going to see, is anybody got any questions? Anybody want to say anything?
Judy, just to interject, I've noticed that 2 students have the same issue when they connect the kits, that they're getting the Wi-Fi error. So just for everyone who does possibly get that error, I'm going to reiterate the message I've told both of them. Power cycle it. So take it out of the USB power, wait a minute or 2, and then plug it back in, and it should work.
Absolutely. What it could also be, Brittany, is that those students have not, maybe they haven't received their kits directly, so it hasn't been pre-flashed with this particular software. So I think that's fine. What we're going to do is at the end of today, we're going to have a look at how we use X in a Box Uploader to load our code. So it's not a deal breaker. We're still going to be able to continue, and they're going to be able to load their cores with lots of different types of code. So that's absolutely great. Thank you. And yes, thank you for reiterating that. Sometimes what do they say? First choice is always reboot. Now what I'd like you to do is I'd like you to try something, a little experiment. And I'd like you to put your fingers over the light sensor. So block the light sensor and then see what it does. What is it doing if I block the light sensor? Anybody going to offer something?
Risa just said the lux drops, and Ivan said a lower lux value as well.
Definitely. And does anybody have their lighthouses starting to actually display, starting to shine a light?
Magdal says yes, and Tafara says yes.
Absolutely. And also you'll see that now the little LED on the core is shining very brightly. So yeah, what I do is that I actually use this as a torch. Okay, because the light is actually bright enough that I can almost use it as like a little night light or something like that. So yeah, I find this this little bit of code for the lighthouse, I find this very useful. So what we're going to do now is we're going to do an experiment. So what I would like you to do is we're going to be going to the break in the next few minutes. So what I would like you to do during the break is to, I'm just pinning myself because I'm seeing Brittany here. There we go. Okay. So what I'd like you to do during the break is to run a little bit of an experiment. I'd like you to take your lighthouse and paper and pen, your little book and your pen, and I'd like you to find 3 different locations with very different light levels, and I'd like you to record in your book or on your piece of paper the lux value as well as the UV index. So I'd like you to find 3 places where you've got 3 different light levels. If you can go outside, that would be absolutely fantastic. Otherwise, also what you'll find is that different types of artificial light can have different UV outputs. So that could also be quite interesting. A little bit of a tip is that when you collect your light data, you know, what I'm doing is my light is directly above me. So what I'm doing is that I'm making sure that my sensor directly faces the light so that when I collect my data, it's falling directly onto the sensor. If I was wanting, I've got a window next to me. If I wanted to see what light was coming through the window, then I would hold it up like this so that I could get the light from the window. So it's very important that what you do is whenever you collect your data, that it's perpendicular to your sensor. And also the thing is, be consistent. If you're going to be holding your sensor in a particular orientation when you're in different rooms or whatever, just make sure that that's consistent so that you can compare apples with apples, whatever that may be. So what I'd like us to do is I'd like you to go and do that experiment. We're going to come back into a much more formal session at exactly 1 o'clock. However, Brittany, Colin, Banele, Nico, Milena, myself, we are going to be here. Brittany's going to be assigning you to different breakaway rooms and mentors, so that we can actually just help you and we can do a little bit of troubleshooting before we come back together again. So when we come back together again at 1, what I'd like us to do is go through those results of the experiment, see what you've observed, and then what we're going to do is then we're going to have a look at the theory behind that. How is that? Why does that work the way it does? And then what we'll do is we'll keep on building our kits from there. Brittany, over to you.
Just before we head out to our breakout rooms, not everybody has been assigned to a breakout room because your Zoom username isn't the exact name or similar to the name that you signed up with. So you might be using your parents' Zoom account. If you know your mentor, you can have join the breakout room. And if not, join a mentor from the province you're in, because the province is next to each mentor's name in the breakout rooms.
Great. Brittany, sorry, you got to treat me like an 8-year-old. How do I find a breakout room?
Okay, so I will open the breakout rooms as soon as we start, and you will be able to join them from the breakout room tab in your host panel at the bottom. It should be next to record.
Great. Wonderful. Thanks so much. And we'll see you all back in an hour. Good. So hi, everyone. Welcome back to our second part of our first workshop. And yeah, so during the break, everybody had access to the breakaway rooms. And also we did a bit of an experiment. So would anybody please like to give some feedback on how their experiment went? We're all ears. Who would like to volunteer their results? Reza, how about you? Reza, Kluta, how about you? Would you like to share with everybody your results?
Hi, Judy. I would like to share my results with the program.
Excellent, fantastic. Yes, please do.
Okay,
do you want to put your camera on, or are you okay just with audio?
I will put on my camera.
Lovely. There you go. Now we can see you. Perfect.
Okay, Judy, for my recorded results, when I went outside, the lux level went from 171,281, and then the UVL was 7.41. So the light intensity outside is much higher than here inside. Because when I took it inside in the kitchen, the lux level was 272, while the UVL was 0.20. And then I also took one in my room where the lux level was much lower. It was 162 lux and UVL was 0.14.
Great. Great. That's fantastic. And do you have any idea perhaps what the reason for you observing that?
Yes, Judy. The reason for my observation or my theory on what is the difference between it is that outside the light intensity is much stronger than here in the house. So that's why the lux level and UVL is much higher outside than here inside. And since my room is dimmer than the kitchen, that's why the lux level is lower in my room.
Okay, and so that light, that more light is that's from the sun, isn't it?
Yes, Judy.
Okay, so also what it could be is maybe also maybe the windows in the kitchen are larger or something than in your bedroom, so you're getting a lot more light into the kitchen from outside. So it could be very interesting. Maybe what you do is maybe when it's dark tonight, when it's dark outside, maybe you could just have a look at the differences again when you're using artificial light in those rooms and actually see. So what is the sunlight contributing, or what is artificial light contributing? So that could be very interesting, a very interesting exercise to run. Okay, so who else would like to share their findings?
Judy, I think Ivan has some interesting findings, and then after Ivan, Kaylin as well.
Great. Ivan, would you like to share first?
Hi, ma'am. I found that putting the light sensor directly under sunlight was almost 10 times more than directing a torch, a normal full power torch at the sensor itself.
Absolutely. Absolutely. So it just shows you actually how powerful our sun is, so definitely. And I mean, absolutely. And Brittany, who else is going to be sharing with us?
Kaylin commented in the chat saying that they have numbers for lux, but they don't have any numbers for UVI. So maybe they'd want to share why they think that happened.
Great.
Record progress.
Okay. Sorry, we were just getting some feedback there. Kaylin, are you able to share with us?
Yes.
I did have lots of trouble getting this to work, but I'm not sure. Is that like supposed to be right where I don't have any numbers for the UVI?
No, not necessarily. Don't worry about that. You know, for example, at the moment, because I'm indoors, I don't have any numbers. So yeah, don't worry about that. What we're also going to be doing is we're going to be flashing more software during the week. And then probably you're going to be seeing some numbers.
Okay.
But what did you notice about your lux levels?
Oh no, I just wanted to like ask if there was supposed to be any numbers.
Not necessarily.
That?
Milena, is that you?
Yeah, if some of you could not go outside to measure.
Milena, I'm so sorry. Somehow you muted in the process.
Sorry, yeah. It's very logical that inside the house there is no UV light because the UV light comes from the sun. So if you only did your measurements inside the house in different parts of the house, you literally shouldn't be having UV measurements.
Absolutely. You're very right. You're very right. So what I'd like us to do is I'd like us to go back to our presentation, because what we've done is we've put together a few slides. Brittany, can you see the slides? I just wanted to make double sure that you can.
Yes, I can.
Okay, fantastic. So let's first have a look at light intensity. What we can see here is, please, this is not to scale because our sun is a lot further away than it denotes in this picture. But the thing is that we have our light source, and in this case, when we're outside, it's the sun, or otherwise, if we're indoors, it's probably some kind of light bulb or source of artificial light. And the thing is that the further we are from that light source, the lower the intensity. And this is actually, it's a mathematical formula. And this is, so let's actually have a look at this. Let's say, for example, this is a light bulb or a torch, as Ivan was saying. So let's say this is our torch, and we are standing 1 meter away from a wall. And what we'll find is that that amount of light being emitted from that torch covers, let's call it 1 square meter, 1 unit of surface area. So if we're 1 meter away, what it is we have a particular intensity that covers 1 square meter. So let's just say that that is 1. If then Ivan, with his torch, he steps back, and he's now 2 meters away from the wall. That same light coming from his torch now needs to cover a much larger area. And so that area is actually 2 by 2 meters, which is 4 square meters. But he still only has that 1 torch bulb. So now the light intensity is 1 divided by 4. So it's actually a quarter. So you can see here, our intensity has gone from 1 unit now to a quarter of a unit. If he steps back a further meter, and now he's 3 meters away. So now the light source is 3 meters away from the source. Now this actually becomes 3 by 3, which is 9. And so now that intensity is 1/9. So as you can see, the further away we are from our light source, it's a dramatic difference. So what we can see here is, if we have a look at these numbers, so it's a unit of 1, unit of a quarter, and a unit of 1/9. What that means is that the light intensity is inversely proportional to the square of the distance. Okay, because what we're doing is we're having to square the distance every time we have a look at it. So it's inversely proportional because it's in the denominator. It's inversely proportional to the square of the distance. So the thing is that when we go outside, our planet is, the thing is, we've got a certain distance from our sun because of our planet's orbit around the sun. It does vary slightly during the year, depending on whether we are at apogee or perigee, etc. But the thing is that what we can do is we can really rely on a particular intensity, you know, for particular seasons that we have. And so if we compare that with a planet that's a lot further away in our solar system, the intensity from our sun, or the warmth and the light from our sun, is going to be considerably less. So if we now take this a little bit further and we say, what is the light that we are receiving from our sun? What we've got is we've got our visible light, which we can see as human beings, as creatures on the planet. What we can see is we've got a particular band that we can view, which we refer to as visible light. Mike, Ivan, I think you walking around, there you go. No, sorry, I was getting a little bit dizzy from your camera moving around. So what we've got is we've got our visible range of light, and that is the colors of the rainbow: red, orange, yellow, green, blue, indigo, violet. And so what we have is we have the red visible light on close to our infrared spectrum, which is over here. And then we have our violet close to our ultraviolet spectrum of light that we receive. So can anyone make any suggestions? Is even if we can't see infrared light, as human beings, how would we be able to detect infrared light? What kind of instruments could we use to detect infrared light? Brittany, if anybody's saying anything in the chat, please say so, because I can't see the chat when I've got my screen up.
It's okay. Riza just mentioned infrared sensors. Liam just mentioned heat sensors, and nobody else said anything just yet.
Okay, both are absolutely correct. What it is, we do have infrared cameras. We have infrared goggles. So that is how, for example, when we need to monitor poaching, or if we want to monitor the movement of animals at night, especially nocturnal animals, so what we can do is we can use infrared goggles, and we can use infrared cameras, because what it is that the body, when the body emits heat, what it is that's interpreted as infrared light. Varisha, I see that you put your hand up.
Yes, Judy. Just one thing that is an example instead of theory of infrared, right, is our remote controls that we use to switch the TV on. Now, most of us, we don't actually think about the simplest thing where, how does our TV come on? And we use infrared light in order to get your TV to switch on. So that's the little front portion of the remote that lights up red, and that actually helps for the TV to come on. So that's like the basic basis of an example in everyday life.
That's a fantastic example. Yes, Risha, thank you very much. Because what we have is that little light on the remote. That's our output, and then on our TV we've now got a receiver as the input. Because that's what you need with communication, is you have somebody who is talking and somebody who's listening. So we have the remote, which is sending the signal, and we have the TV, which is receiving the signal. Banele, I can see you also have your hand up.
Yes, this is more of a silly question, but I've heard that certain animals can see beyond the visible spectrum, like with cats and dogs. So if we can only see visible, has there been any studies that prove that certain animals do sometimes go beyond the visible spectrum, where they can start seeing in other spectrums?
Anela, I think you're absolutely right. It's also something that I've also come across. I have to admit, I didn't study biology, so My experience of animals is probably restricted to the dogs that I've had during my life. So the thing is that maybe there's somebody in the group who has studied biology or who is studying biology who could help us with that question. Lungeliseli, I can see that you have your hand up. Maybe you're going to help us with this question.
Yes, I think I can try. Yeah, I studied medical robotics and prosthetics here at DUT. So I have a background in medical.
Sorry, we're really struggling to hear you. I don't know if you want to hold the microphone maybe a little bit closer or something. We're getting a lot of feedback and echo.
How is it now?
That is a little bit better. Great, thanks.
I have a little background in the medical side since I've studied medical robotics and prosthetics here at DUT. So anatomy and physiology, I've done it. So to answer the question, humans have, pupils which are less constricted to control the light which goes into the eyes. If your pupils constrict, that's the small portion in the middle of the eye. It controls the light going in and the light going out. So in a dark place, if you stand in a dark position, your pupils dilate so you can see more and light can penetrate more. When you're in outside, your pupils constrict so that light cannot damage your eyes. So it allows very limited, light to go into your eye. So that's a brief. I don't want to go into deep. So yeah.
Absolutely fantastic. I can see that the chat is full of people saying yes. Riza is saying snakes has something similar to infrared sensing, using pits to detect heat. And then Tafaro is saying spiders and many insects can see ultraviolet light. Absolutely. I certainly believe that certainly predators, carnivores, are definitely able to detect, when there's food or prey around, so they can certainly pick up the heat and they can pick up that heat signal. So yes, thank you very much for that. And so yes, the infrared is very much more kind of towards the heat end of the light spectrum, and then ultraviolet is on very much the shorter wavelength and much higher energy than the visible light or the infrared light. And it's really interesting because the thing is that we always relate heat to energy, because of course we use a lot of energy to create heat for ourselves. As human beings, it's crucial to our survival, is that we're able to maintain our temperature and that we don't freeze to death. But in fact, heat is a relatively low form of energy. And if we get into the ultraviolet zone, that's actually very high energy, and it can be unbelievably damaging to us, being exposed to ultraviolet. So the thing is that when we are out in the sun and we find that we're getting warm, or we find we're getting hot, we find that we're feeling as if we're starting to burn up, that's because we're being exposed to the infrared light. Another use for infrared light is keeping food warm. So in restaurants or takeaways, once the food's been prepared, what they'll do is that they'll put it on a shelf underneath these infrared lamps, so it keeps the food warm. So what we can see is from this graph, which is quite interesting, we can see that the wavelength and the frequency are inversely proportional. And then we can also see here the number of photons. So in this visible light range, you can see we've actually got a very, very, very high number of photons. And that is very important when it comes to solar energy production, because what we're doing is we're actually utilizing the energy from those photons for our solar energy production. So if we go to our next slide, this has a look at ultraviolet, UVA, B, and C. So let's just have a look here. So here's our sun. Of course, please, this is not to scale by any means. So what it is that the ultraviolet spectrum is split into three, ultraviolet A, ultraviolet B, and ultraviolet C. Now we can see here from this diagram that the ozone layer that is sitting, this ozone layer sits anywhere between 20 and 30 kilometers in altitude above our planet. And that stratospheric ozone, or that ozone layer, is absolutely crucial. And what it does is it absorbs the ultraviolet C. The ultraviolet C is by far the most, very, very, very most dangerous ultraviolet light for us as living organisms. And so the thing is, that is why it's so crucial that we have our ozone layer. And that is why when we talk about climate impact, and when we talk about certain gases that are impacting or destroying our ozone layer, that's really, really, really important. And that's really critical, because that ozone layer is protecting us from ultraviolet C. However, there is one other source of ultraviolet C that we do find on our planet, and that is from arc welding. So arc welding is when you have an electrical arc, and it's actually causing a short across the anode and the cathode, and that's used in very, very, very high energy welding, especially with stainless steels. And the thing is that you know, when I was an engineer, I quite often used to visit factories, and I would become very, very concerned, because there would be people who were arc welding, and what they'd done is that they'd taken the helmet off, or they'd taken the gloves off, because what it was is that they were getting too hot. Physically, they were getting too hot and sweaty with all this protective gear. The problem was that they were arc welding, and they were being exposed, and they were looking directly at this UVC source, which really causes blindness, and also being exposed to that ultraviolet C is really, really, really bad for skin cancer. Because the thing is, unfortunately, we can't actually feel that it's burning us when we're exposed to it. So thank goodness for our ozone layer. And then ultraviolet B, and also, please, if you need to wear your protective equipment whenever you're doing anything like welding. And then UVB can penetrate the ozone layer. A lot of the time it gets blocked if there's a lot of smoke, if there's a lot of humidity, that will absorb the UVB, and then the UVA really comes through most things. So yeah, so UVA is really, it contributes a lot to aging of the skin and wrinkling. Whereas UVB, what happens there is that that's very much responsible for when our skin burns. It's mostly because of the UVB that we are receiving. So on your kits, it says UVI, which is the UV index. So what it is that the UV index is calculated from a combination of UVA and UVB. And what it is that it's an index, which is really actually a factor. Because the thing is that as you can see with your lux levels, you've got very high numbers, you know, usually in the hundreds or the thousands or even hundreds of thousands. And the same with UVA and UVB. So the UV index is a really nice, convenient way to have a look and see how dangerous is it, or how safe is it. So if you're outside and you're exposed to a UV index of more than 7 for more than an hour, you really should be putting some kind of sunscreen on. So yeah, that's it's a really nice indication for us in terms of how exposed are we and how dangerous is the environment that we're in. Now what we're going to do is we're going to quickly switch back to infrared. So what we have is we did see that the atmosphere, especially our ozone layer, was absorbing all the UVC, and it was absorbing some of the UVB. But when it comes to the infrared, okay, this is of course not to scale. So the light from our sun, as we saw earlier, includes also infrared radiation. So what we have is we have this incoming light or incoming solar radiation coming through our atmosphere. And as that light comes through the atmosphere, our atmosphere absorbs the heat from it. It absorbs the infrared, but it cannot absorb all of it. So what happens is that the light then hits the surface of the planet, and that's absolutely fine. That's why surfaces get warm. That is why, for example, a black tar road gets a lot hotter than grass, because the black absorbs the infrared, absorbs the heat. Our challenge is when we have areas that are highly reflective, and what happens is that it then starts reflecting that light. Then what happens is that the light, as it's reflected out of the atmosphere again, the atmosphere reabsorbs the infrared. So what we have is then we have this double absorption in terms of the infrared, and that is why we have this greenhouse effect coming to be. Brittany, I could see that maybe you put your hand up.
Yes, I did. Maxwell asked a question that relates to what you were talking about, but also the previous slide. You was talking about why is there tropospheric ozone and not only stratospheric ozone? So just maybe if you want to touch on the difference between the two and what its effect is on the climate and the greenhouse effect.
Okay. Those questions are very much on the far edge of my knowledge, but let me try. Okay, can you see the slide, Brittany?
Yes.
Okay, so what we can see here is that we've got this ozone layer at a particular altitude. Let's take other gases, for example. Let's take our atmosphere is made up of roughly 79% nitrogen. It's about 19 to 20% oxygen. And then there's 1% of argon, and then some other trace gases. And carbon dioxide is actually within that final 1%. And our other greenhouse gases are in that final 1%. And now I'm talking as if we were at sea level. As soon as we get to higher altitudes like Gauteng, Johannesburg, where we are relatively high up in terms of altitude, that level of oxygen drops from 79% to about 77, 76%. And the reason for that is that oxygen is slightly denser than nitrogen. So what we're going to find is we're going to find that those gases we find so oxygen we find more of it at lower altitudes. When we take ozone, for example, ozone is, what is the opposite of dense? Light, I guess it's light. Ozone is a very light gas. So what happens is that the ozone, it rises in our atmosphere. And when it gets to that particular altitude, which is roughly around about 30 kilometers, that is where it's stable. Okay, that is where it's stable in terms of with the depth of our atmosphere. That is where it's able to, it's almost, if you were to consider it, it's like buoyancy, because air is also a fluid, gases are fluids. So what it is it's because of its density, it's very happy and it's very stable at that altitude. So we may have some molecules of ozone at high altitudes or lower altitudes, but really it's concentrated in that area. I hope that helps answer the question.
Yes, I think so. And I did just drop a link to an article about the ozone problem that explains in detail the difference between tropospheric ozone and stratospheric ozone.
Great, fantastic, excellent. Okay, so what I'd like to do now is I'd like now for us to have a very open discussion to say, okay, so what we've learned quite a lot. Yes, Brittany, you have your hand up. Brittany, I can't hear you.
Sorry, that was an old hand, my mistake.
That's okay. It's good. Just don't do it during an auction. Okay, so what I'd like us to do now is have a pretty open discussion about robotics. So how can we take what we've learned now regarding light, whether it's visible light and lux, UV, ultraviolet light, UV index, how can we take what we've learned there and say, how do we apply that to robotics? Because every single thing we're going to be doing in this program over the next number of weeks is we're taking STEM, science, technology, engineering, and mathematics, and we are applying it to robotics. So what we want to do is we want to have a look at what is the job we want our robot to perform, and why do we want it to perform that job or that operation. And what we saw earlier is that whenever we want to build a circuit or we want to build an instrument or something like that, we need four things. We need input, output, processor, and power. So Varisha, I could see that you had your hand up.
Yeah, just a quick note on that for the kids today. It's a pleasure meeting you all. I'm also one of the mentors. I just want to tell you that you have to think of science as in your everyday life, not as in something out there that is not unachievable. This is things that you know that apply to us in our daily lives. If you look at us, we went from no phone to a phone. Now we have iPads, we can see each other, and we've got new fancy TVs and all of those things. So we need to, while you're thinking about robotics in the back of your mind, always remind yourself these are practical things that you can do in your everyday life and can achieve in your daily lives. Even if you look at an aircon uses a system to conduct. That is all a part of robotics. So it's not far out there and not to scare you, but basic, simple things do apply for robotics.
Varisha, absolutely, yes. Thank you very much. Is there anybody else who would like to give some input here? Okay, great. So what I would like you to do is please have a scratch around in those boxes that you received with your X in a box chips, and let's have a look at what else you have, what else you've received.
Judy, Riza just dropped a message in the chat saying maybe we can take the knowledge from what we learned to make a robot that can maybe perhaps detect the differences between UV and detect the harmful light and warn us and tell us about them.
Definitely you could. Definitely you could. Brittany, I think that was one of the projects that you worked on once. Maybe if you want to share something there.
Yeah, that was actually one of the projects I worked on when I was interning. So we made a little device like we built today. And basically I connected it to this app called Blink, but it's basically just an app that you'd have on your phone where you have setup widgets, and it basically gave me notifications when I was in a certain location that had above a certain threshold of UVA and UVB readings, and then it gave me that was a warning. And then when I was in low light, it would tell me low light or high light and if I was in shade or not. And that's just a really simple example of how you can use modular electronics and IoT.
Definitely, yes. What you could do is, I can see that Raina has made a suggestion that what you could do is you could build an app that it could send you a warning to say, wow, get out of the sun, or for parents to say, get the children out of the sun, or embarrass them again by smearing more cream on them. So certainly one could do that. So I'd like you to have a look. What else do you have in that kit of yours? Okay, so yes, you certainly do. You have a component called SW02. Where's my SW02? Here it is. So here, this is a weather sensor weather 02. And so this little chap right in the middle of this sensor block is going to give us atmospheric pressure, temperature, air temperature, as well as relative humidity. So that's why it's called a weather sensor. Very, very, very useful, because we're going to be doing quite a lot of experiments with that. Somebody has also said, what about SW07? Well, when you unpack it, you'll see that this is what it looks like, and mine's dirty. And the reason for that is because this is a soil moisture sensor. So I've actually had this one in my pot plant. That's why it's a little bit, got a little bit of mud on it. And so what it is that this is a soil moisture sensor, and what it does is it measures the conductivity between these two probes over here, and it then relates that to a signal in terms of soil moisture. The thing is, because water conducts electricity, so the more water there is in the environment, the more moist that soil is. So what you'll find is that when you've got it in just normal air, it's going to give you a reading of 0. When you put it in water, it should give you 100, and then anything in between. Brittany, yes.
Yes, Abdul Kayoum just sent me a direct message asking what's a servo driver, and I noticed that Ivan also mentioned the servo driver OC05. So if you want to highlight that component next.
Okay, so yes, here it is. OC05. So that is output control 05. I love this component. Okay, so this is a servo driver controller. Let me just open it up. Thank goodness it's in a Ziploc bag, so I can put it back again. And so you'll see over here what it has is it has a whole bunch of pins. Okay, so it's got all of these pins on it. And what this means is I can actually connect up to 8 different servos. So what a servo is a little motor. And what it is it's used a lot on robotic arms. So, or, you know, to tilt or pan any objects, things like that. So what you can do is you can connect up to 8 on this controller. So what you would do, and this is of course an output because it's OC output controller. So what you would do is in your circuit, you could have, I'm getting my input could be my light sensor, and my light sensor is telling me that maybe I've gone into the shade because my lux level has gone down. And then my code, my Arduino code could then tell my servo, please turn the solar panel. Please turn the solar panel because I've gone into the shade. So maybe I want to move it into the sun again, something like that. So yes, these are very, very, very useful. And they are probably crucial when we want to build our robots, if we want our robots to actually move anything, do anything in terms of movement, then we're going to want that OC05. Anybody else got another output?
Yes, somebody mentioned the OC01 high current DC switch.
Okay, right. So output control 01. So let's open up this chapter. So yes, what it is it's a DC switch, which is direct current switch. So let's say, for example, you want to actually you want to open up a circuit. So what you can do is you can see over here, it's got these. Let me see if I can get it close enough. You know, you would use a little screwdriver.
Very clear.
So you could put the little screws in. You know, so what you could do is you could screw some wires in for direct current. Also for alternating current, you can see it's got the plus and the minus for the input and the output, etc. So this would be, for example, in a room, my light sensor is telling me that the light has dipped. I want to turn on a lamp. So what would happen is that your output control would then be able to turn on the lamp, because what it would do is it would open the circuit for turning on the lamp. You could use it for opening and closing doors that have motors, like maybe, or gates that run on motors and things like that. Brittany, you have your hand up.
Yes, Reza just sent an interesting comment about OC05. He said, so could we make a robot that controls solar panels to follow light to get the most power from the sun, telling the servo to move the panel towards the light?
Absolutely. Now we're talking. Now we're talking. So,
and then,
yeah.
Oh,
carry on.
Sorry to interrupt. Somebody also mentioned the gesture sensor SL06, but if you want to continue what you were saying about Reza's comment, and then we can hop on to that.
Okay, we're certainly going to come to the SL06, definitely. So, yes, what it is that that is a real application. What I'm going to do is I'm just going to share my screen again, because what it is that we're taking this and we're saying we're having a job that the robot could perform. So yes, where we have solar panels, and what we could do is we could now have a robotic arm that is moving the solar panel to optimize the amount of electricity we can generate from that solar panel. And so, yes, what we've got is our input would be our light sensor or our light level, and our output would be to the arm to say, I need you to move. And we could have some kind of a feedback loop, definitely. So what we also have is that some of you, not all of you, have received the SL06. So that is another light sensor. And what that light sensor does is it detects gestures, or also proximity. It's a proximity sensor. So the way that sensor works is it doesn't only receive light. What it does is it also emits. So what it's doing is it's constantly emitting light, and then it's measuring the bounce. So it's measuring the light that gets bounced back to it. So what you could certainly do with that gesture sensor is you could have a swipe as your input. So you could maybe say, when I swipe across the sensor, I want you to turn the light on or turn the light off, or turn a pump on, turn a pump off, things like that. So that sensor is very, very good in terms of what you can do is you can now use your sensor to convey instructions. So now you can really start having very much more of a manual input using that sensor. Okay, Muna has mentioned a PG01. So PG01, if anything has a P in it, it's because it's a power unit. So what we have is we've been using our USB power, which is IP01. And so your PG01 is your power generic 01. You know what, I actually don't have one close by. If anybody wants to just open the bag and hold up that PG01 to the camera, that would be great, so that we can all see it. Because you'll see what it has is it has these screw terminals. So what you could do, there we go. Yes, absolutely, Brittany. What I'm going to do is I'm going to pin you. And I can see Liam's also holding it up. So yes, what you have is you have these screw terminals. So what you would do is you would take your normal wires that you would have from your plug in the wall, and then what you would do is you would add that. So you could power your circuits using that unit instead of using your USB power, etc. So because Brittany, thank you, that's fantastic. So the thing is that we can't always use our USB power because especially if we're going to have especially if we're going to have an instrument that we are running outdoors, or maybe we are running it in a wilderness area or on a farm or something like that, we're going to have an alternative power source. So what we could do is we could use that PG. What we could also do is we could also connect that PG01, we could connect to our solar panel. So our solar panel could also be feeding our robotics power. So we could certainly do that. Any other instruments that you have in your kit? If I remember correctly, I think that's it.
Yeah, it is. And then Nico mentioned the gesture sensor will work well in the current COVID environment as there is zero touch involved.
Nico, you're absolutely right. Yeah, we don't want to be touching things. So yeah, it's very nice as an input where you don't necessarily touch anything. Yeah, because ultraviolet, actually now during the pandemic, ultraviolet is actually used a lot to kill viruses. So yeah, there's many of the stores, like for example the grocery stores, etc. They have these ultraviolet emitters, which are basically almost like little robots that drive around at night, emitting ultraviolet light to kill the viruses that are in the air, that are airborne, so that when people come into the store the next day, hopefully it's free of virus. And they certainly can't run it while people are there because it's so damaging to us. So yeah, what I'd like us to do is that I'd like us to see how we're actually going to use this. So what I would like is in the last 10 or so, 10, 11 minutes that we have together, is I'd like to share with you that what we're going to be doing is that we're going to be flashing a new code to this core. So you all have the CW01 as your core. And what it has at the moment is it has the lighthouse code on it. And what you're going to be doing is you're going to be flashing new code to it. And I'm going to take you through that process in the next slide. And then what you have is that you have 2 experiments to do this week. What I'm going to be doing is that I'm going to be sending you all an email after this session with your experiments, an experiment procedure, and exactly how to submit those experiments, your results of those experiments. So the first experiment is going to be, is there a relationship between natural light and temperature? So what you're going to do is with the new code on your kit, you're going to identify areas outside. It has to be natural light, not artificial light. So it's going to be sunlight. And then you're going to conduct an experiment to see if there's a relationship between natural light and temperature. The second experiment you're going to be doing is, does the fridge light go off when I close the door of the fridge? Okay, so that's another experiment you're going to be having a look at. And then you have 2 quizzes to be completed. And then next week, what we're going to be doing is we're going to be building data dashboards so we can do a lot of remote sensing. So we don't necessarily, we're not going to be only looking at our screen itself. We're going to be posting data via internet to dashboards and things like that. So we can actually start really doing some great data science and design and engineering. So what I want to do is before I show you anything else, I'm just going to take you to those quizzes quickly. Let me just take you to those quizzes. So let me share my screen again. So what I did is I called them up during the break. Okay, so can you see the onboarding with X in a box quiz, Brittany?
Yes. Yes, I can.
Terrific. Okay. So what it is this is a quiz out of 50 points. Please, that we would really like you to complete. And let's just read the instructions here. It says, in this quiz, we look at the fundamentals of modular electronics and how we build electronics instruments. Some questions have multiple correct answers. Select those you feel are correct. And this is important. Only select the answers you feel to be correct. Don't simply select all of them. Okay. So yeah, I don't want you to go through and just select everything because that means nothing. I really want you to identify those that you believe are correct and only select those. As a refresher, you can watch the 6-minute video and I've put in the YouTube link. So if you want to, before you go through this quiz, watch the video and then you can certainly answer all the questions because all of the answers are definitely in the video. Then the second quiz is natural light quiz. In this quiz, we look at the properties of natural light, and there is another link, okay, to a 10-minute lesson on light. So, that's what you're going to have. I'm going to be sending you both those links. So no need to stress about that. Okay, are there any questions there before I move on to how you're going to do your code?
No questions in the chat. Maybe someone has a question that they didn't type.
Milena, I can see you've raised your hand.
Yeah, there is a question from Liam Disaki. When are we going to learn to use the other chips? And I'd like to answer that we are working in our own speed, and every lesson has a little bit of learning and skills in it. And Liam has to trust us to guide him in the beginning, and then he can teach us something when you guys learn, all of you, when you guys learn to how everything works, and you can work into area of your interest. It could be applied into farming, into micro farming, into many other areas.
Milena, yes, absolutely. Thank you very much. Because what we're going to be doing after today is you're going to be building this next kit. So while I go over and get my kit, Mlungeleseli, I can see you have your hand up.
Oh yes, Judy. I wanted to check. There's some very interesting. One of the circuit. You said it's SW07 for soil moisture sensor, right? So I was wondering. Let's say I'm creating maybe a artificial prosthetic hand. I heard that you say if you dip it in the water, there will be, the read will be 100, and if it's in the air, it will be 0. So my question is, if you dip it in water, so it doesn't get affected or maybe damaged, that's the question. Or can these circuits adapt to water, or there are certain circuits that cannot?
Yeah, absolutely. We're dealing with electronics. We're dealing with electronics and we're dealing with electrical circuits. So in general, we don't actually want to be running things in water. So when we have a look at our soil moisture sensor, it's really actually only these sections that go into the soil. We don't want more to go into the soil, because what will happen is if, I mean, the connectors are great, the connectors are great, but the thing is you can't actually immerse it in water because then you're going to wet your electrical circuit. So there's definitely limits to how much you can immerse things. So in fact, the only one that really gets moist is going to be the soil moisture sensor, and it's only these two, this anode and this cathode that goes into the soil. The rest, the focus is very much on measuring air. So that's relative humidity of air, atmospheric pressure, as well as air temperature. And then of course we look at light. In this program, that's what we're going to be covering. But yeah, you're absolutely right. We want to be careful about actually putting our circuit in water. We don't want to do that. Not this time around. Okay, what I'd like to do is, may I just go back? What I want to do is that I want to take us to what we're going to be building. Okay, I know this looks very busy, but what I'm going to be doing is I'm going to be sending you these links. Okay, you're going to be flashing new code to your core CW01, so that what we can do is that we can actually we can start working with all of our multiple sensors. Okay, so let me actually explain what I'm talking about here. Now, as I mentioned before, sorry, I'm just trying to pin myself so that I show on the video. Okay, that's great. So as I mentioned before, what we have is we have this core CW01, and this is flashed with Arduino code. It's arrived to you pre-flashed. So the thing is, what's going to happen is that you're going to take this core and you're going to take your IP01, okay, which is actually doubles up as a programmer. Okay, so you're going to connect them directly. Please make sure that they're connected correctly so you can see the CW01 and you can see IP01. Okay, these are the only two components that you're going to be using when you flash your next series of code. Okay, so what it is that we've developed a number of packets of code, and what you're going to be doing is you're going to be flashing another one. And the way we do that is we have a tool that we call X-in-a-Box Uploader. And there is a very, very good video. I'm sending you the link of how you can download X-in-a-Box Uploader, whether you've got a Windows machine or you've got an Apple. What you can do is you can download it. And X-in-a-Box Uploader is an app that we use to load all of our different coding packets. So what will happen is that I'm just getting this out as a demonstration, because this is what I use for my computer because I don't have a USB port. But what you'll be doing is that you'll be inserting your IP01 into your USB port, connected to your core. And then when you open up X-in-a-Box Uploader as the app, you'll see that it'll detect that you have something in your USB, and then it'll give you a drop down. And then what you'll do is you'll select your code packet. And I'm going to go back to that, which one you select. Okay, once you've done that, once you've flashed your code, what it's also going to do is it's going to ask you for your Wi-Fi credentials. Now, this is a CW01. Sorry, something just fell over. CW01, which means Core Wi-Fi 01. So what it is that this little antenna here, that's actually a Wi-Fi antenna, and this is actually a Wi-Fi hub. So what this is going to do is this is going to connect your sensors via Wi-Fi to the internet. Okay, so and what you're going to need to do is you're going to need to connect to the internet so we can actually start doing some real IoT projects, so we can start working with dashboards, etc. So to go back to X-in-a-Box Uploader, when you flash your code, it's going to be asking you for your Wi-Fi credentials. Now, those Wi-Fi credentials are the username and the password for your home Wi-Fi, Or otherwise, what I do is quite a lot, I use my phone as a hotspot. So what it would be is it would be the name of my phone or whatever I want to call my hotspot plus my hotspot password. Unfortunately, these components can't do high-level security logon. So, for example, when you're at school, often what happens is it needs a 3-level logon, username, password, and maybe some other credentials. Unfortunately, this can't do it. It works very well with simple Wi-Fi routers like we would have at home, or maybe a guest Wi-Fi network, or otherwise a hotspot. So it's going to ask you for those credentials when you're flashing your code. Now, what will happen is once you flashed it, you disconnect it, and then I would like you to add your soil moisture sensor, SW07. I'm going to send this all to you in the email, so don't worry about having to make notes now. But you're going to add your SW07. You're going to add back your light sensor, and you're also going to add your SW02, your weather sensor. Okay, so you're going to have 3 sensors connected. If you like, you can put your screen back. I do, but you don't necessarily need to because you're going to be able to see your data on the internet. So what you're going to have is you're going to have 3 sensors. You're going to have your weather sensor, your SW02. You're going to have a light sensor. By the way, it works with both the SL01 as well as the SL06. And then you're going to have your soil moisture sensor. So that's going to be great. You'll have 3 different inputs of those 3 sensors. And then your core and your USB power. And if you like, you can also keep your screen. So what I'd like to do is I'd like to go back to sharing. Are there any questions right now before I go into more detail, Brittany?
There aren't any directly related to. Izuna did ask about the SW01, which I think he meant CW01, and I did answer his question.
Okay. There are some people who have an SW01 because maybe they've got a kit from a teacher. But that's okay. That's all right.
It was with regards to flashing.
Okay. Okay, so then it would have been the core. Okay, so then it would have been the core. That's great. Okay, so this is where it's important. As I mentioned, what it's going to be is there's a video to show you how to install X in a Box Uploader for both Windows and Mac, including the various security obstacles that you could come across, because there's some items you'll have to select or deselect. The video does use YouTube chapters. So it allows you to jump from one chapter to the other depending on your operating system. As I mentioned before, you'll connect your core, your CW01 and your IP01 together. Please don't put any of the sensors on it while you're flashing or before you flash. Okay, Brittany, you have your hand up.
Yes, I got a direct message about asking, is there a due date for the quizzes? So that might be a useful answer for everyone, if you just want
to. Before next week's workshop. So let's say by Friday evening. That's good. That's good. I'll put that in the communication. That's great. So what you'll do is you'll insert your IP01 into your USB port on your computer, because it's your computer that's going to communicate the code. Now this is where it gets important, is that there are different coding packets depending on which light sensor you have. most of you have the SL01. So what I would like you to do is when you select the coding packet, you're going to have a drop down. I would like you to select pot plant. If you don't have the SL01 and you have the SL06, then I will need you to select the packet that's in the drop down that's called UNDP STEM. Okay. Brittany, other questions?
There aren't any other questions currently in the chat.
Okay, great. So what we're going to be doing is now, Liam, now we're going to start using all of our sensors, and now we're going to build a kit that's really, really robust, that we can start looking at multiple experiments and a whole bunch of things that we're going to be doing. So what I'd like to do is let's actually just go back to what are those experiments that we're going to be doing for next week. Okay, so the first one is there a relationship between natural light and temperature? That means that you're going to need to have configured your kit, because right now your lighthouse is only giving you a light reading, a lux reading. What you need is a temperature reading, so you're going to need to have your weather sensor connected, which is your SW02. So once you've flashed your new code, you'll be able to do that experiment. And then also, does the fridge light go off when I close the door? I'm going to leave that very much to all of you of how exactly you want to do that experiment. Okay, and then of course, yes, the 2 quizzes to be completed. So right now, what other questions do we have before we conclude today's workshop?
There isn't anything in the chat, so I'm assuming you want to open the floor for people to unmute themselves and ask the questions.
Please. Okay, so it looks as if we don't have any questions. So what we did is, when we originally communicated, when we originally mentioned the workshop days, what we did mention is that between 2 p.m. and 4 p.m. every single Wednesday, we were going to have a catch-up session. So those sessions are very much for if you want to do some troubleshooting, if you've got a challenge with something, maybe you're not able to flash your software, maybe you want to find out how you can conduct your experiments differently or better, all of that kind of thing. So it's not a formal workshop on the Wednesday. Those Wednesday sessions are very much an opportunity for us to get together if we would like to. So yeah, if you have any more questions or whatever that come up later while you're trying to do things, then join the session on Wednesday, and then we can definitely address everything. Brittany, I'm just thinking about, in terms of the breakaway rooms that we have and the mentors that we assigned. How would you like to take that further?
I'll have a similar setup for next session, where the rooms will be named after the specific mentors, and I'll use the same assignments as we ended with this week, but I'll also leave it open for the students to jump between rooms and go to different mentors if they so feel.
Absolutely, absolutely, great. So thank you everybody for joining us today. And as I mentioned, what I am going to do is I'm going to make the video available. I'm going to be sending you all of the links that you're going to be needing, and also as well as an invitation to Wednesday's workshop, catch-up workshop. That is definitely not mandatory. Join if you can. That would be absolutely wonderful, because that is our opportunity to get together again to answer any questions. With that, I'd like to say goodbye for today, and looking forward to seeing you all next week and taking it through many more steps.